Assalamualaikum and hi everyone. Today, my team and I are pleased to present our GUI-based group project, which is the calculator and decimal number converter. Before we dive into the technical details, I would like to introduce the team members who made this project possible. My name is Alifah Athirah and I am joined by my colleagues, Isha Nur Daneea, Fadzreen and Hedi. In this presentation, we will be covering 8 key areas, including introductions, project objective, GUI components use, functional requirements, main outputs, object-oriented programming concepts that we apply in this project, task distribution among group members, and lastly, conclusion. Now, I will pass over the next slide to my colleague for the introduction.
Hi, my name is Alifah Hedi. My student ID is 2025227686. Good morning, everyone. Our project focused on developing 2 Java Swing GUI applications, a basic calculator and a number converter. The calculator is designed to handle arithmetic operations, advanced mathematical functions, and memory features, while the number converter transforms decimal number into hexadecimal and binary format. The purpose of this project is not only to create user-friendly applications, but also to apply object-oriented programming concepts and event-driven programming. By combining Java Swing component with responsive GUI design, we aim to deliver an interactive and efficient desktop experience.
For objective, our primary objective for this project center on developing user-friendly GUI application using Java Swing and practically applying core object-oriented programming (OOP) concepts. Furthermore, to ensure interactive and engaging user interfaces, we will implement event-driven programming to build 2 key tools, which is a calculator capable of handling both standard arithmetic and memory operations, as well as a highly accurate number converter designed to transform decimal values into hexadecimals and binary formats. Therefore, by tackling this real-world GUI project together, we aim to significantly enhance our collective problem-solving, programming, and teamwork skills.
Moving on to the next part of our presentation, we will discuss the GUI components that were essential in building our application. As you can see on this slide, we utilize several key Swing components to create an interactive interface. First, JFrame. This serves as the main window of our application. Second is JPanel. We use this to organize and group our various GUI components together. Third, JButton. These are used to trigger specific functions when a user clicks on them. Fourth, JTextField. This component is crucial for displaying the user's input values and the calculated output. Next, JLabel. We use this to display text labels and show the current memory status in the calculator GUI project. Additional GUI components that we use are Action Listener. This is responsible for handling button click events and overall user interaction. Other than that is Border Layout. We use Border Layout to arrange our components into specific regions of the window. Next is Grid Layout. This helps us organize our buttons into a clean, structured grid. We also apply Line Border components. This was applied to add borders around components, giving the interface a cleaner, more professional look. And lastly, Image Icon. We use this to display the application's icon.
Now I will explain the functional requirement of our project. Our project consists of 2 applications, basic calculator and a number converter, each designed to perform a specific functions for users. Starting with the basic calculator, it supports 4 basic arithmetic operations, which are addition, subtraction, multiplications, and division. Besides this, it also includes advanced functions such as square root, percentage calculation, reciprocal, and sign change for a greater flexibility. In addition, the calculator provides memory functions including MC, MS, MR, and M+, allowing the user to store and recall, clear, or add values to memory. It also includes backspace, CE, and C button to edit or clear input, making the application more convenient and user-friendly. Moving on to the number converter, the application accepts integer entered by the user and automatically converts it into hexadecimal and binary formats. To improve reliability, the application also includes input validation. If the user enters an invalid value such as letters or decimal number, the system displays an error message asking the user to enter a valid integer. Finally, the clear button removes all inputs and output value, allowing the user to perform another conversion quickly and easily. Overall, these function requirements ensure that both applications are accurate, efficient, and easy to use while providing a smooth user experience.
Our application delivers two main outputs designed for efficiency and accuracy. On the left, we have a fully functional calculator that seamlessly performs basic arithmetic alongside advanced mathematical operations, complete with traditional memory functions and instant result display. On the right, our number converter simplifies data translation by instantly converting decimal numbers into hexadecimal and binary formats, complete with built-in input validation to ensure flawless accuracy every time.
In building these applications, we apply several key object-oriented programming concepts. The first one is a classes. We create separate classes for the calculator and the number converter. The second one is object. Components like JFrame, JButton, JTextField, and JLabel will instantiate as object perform the interface. The third one is a methods, which is function where implemented to perform calculations and conversions. The fourth one is encapsulation, which is the data and the methods were organized within classes to keep the code structured and manageable. The last one is event handling. Action listener were used to respond to user interactions, such as button clicks, ensuring the applications were interactive and responsive. This concept allowed us to design software that is modular, usable, and easy to maintain.
Now let's see task distribution among group members. Our group consists of 4 members in total. Me, Alifah Athirah, as the first member, was assigned to develop the calculator functions, including arithmetic, memory operations, and error handling. The second colleague is Isha Nur Daneea. She assisted with coding, testing, and integrating the project components, performed system testing, and prepared the presentation slides and documentation. The third member is Fadzreen. Fadzreen designed the GUI layout and interface for the calculator application and assisted with coding, debugging, testing, and integrating the project components. And last member, we have Zarifah Hedi. She assisted with coding, debugging, testing, and integrating the project component as well. Now, I will demonstrate the functionality and key features of our calculator. Starting with the basics, we have ensured that the calculator handles standard arithmetic operations accurately. For integer calculation, for example, let's try 10 plus 5, which gives us 15. If we then subtract it by 3, we get 12. Moving on, let's multiply 12 by 4, and this gives us 48. And finally, I try to divide 48 by 2, and this will return 24. We have also implemented continuous calculation logic, which means I can perform change operations like 5 plus 5 plus 5 plus 5 without needing to hit equals every single time, and this will result in 20. To ensure our calculator is reliable for more than just whole numbers, we have utilized the double data type for all our calculations. For decimal handling, let's test 5.5 times 2.2, which returns 12.1. Also, if we take 10.5 divided by 2, it results in 5.25. To further demonstrate our precision, I'll try divide 10 by 3. As you can see, the calculator returns number with long decimal places, which prove that it maintains high precision for complex floating point divisions. Beyond basic arithmetic, we have implemented advanced functions and strict error handling. For instance, the square root of 25 is 5, and the reciprocal, or 1 out of x of 4, is 0.25. Regarding error handling, we have safeguarded against mathematical impossibilities. If I try to divide 5 by 0, the calculator handles this gracefully by displaying a math error message. instead of crashing, ensuring a stable user experience. Now, let's take a look at the memory and reset controls. First, for the memory accumulator, I will try to save 10 by pressing MS, and you can see the memory label at the top updates to show that value. If I calculate 5 times 4, which is 20, and press M+, it adds this to the existing memory. Now, when I click MR, it recalls 30, confirming that the memory is functioning perfectly as an accumulator. I will clear this now by clicking MC or memory clear. Finally, we have implemented 2 levels of clearing to improve the user experience. Let's look at the CE or clear entry function. Suppose I want to add 10 plus 5, but I accidentally typed 50 instead of 5. I can simply press CE to clear the incorrect 50, and I can immediately type the correct 5 to complete the equations as 15. On the other hand, if I want to start a completely new calculation, I can just press C button. This clears the display, reset the operator, and gives us a fresh start. In summary, our calculator is designed to be robust, precise, and user-friendly.
Now I will demonstrate the number converter application. This application converts a decimal integer into its hexadecimal and binary equivalents. First, I enter a whole number into the decimal text field. For this demonstration, I will enter 255 and press the Enter key. The application immediately converts the value. As you can see, the hexadecimal result is FF and the binary result is 1111111. Next, I will enter a number with a decimal point such as 12.5. Since the application only accepts integer values, it displays an error message. Please enter a valid integer. Similarly, if I enter letters such as ABC, the same error message is displayed. This input validation helps to prevent invalid data from being processed. Finally, I click the clear button to remove all input and output values, allowing the user to perform another conversion. This demonstrates that the number converter is simple, accurate, user-friendly, and ensuring that only valid integer values are accepted.
In conclusion, this project successfully produced 2 Java Swing GUI applications, the basic calculator and the number converter. Through this work, we demonstrate the use of object-oriented programming principle, Java Swing components, and event-driven programming. Beyond the technical aspect, this project strengthened our teamwork, problem-solving, and programming skill. Overall, it gives us valuable experience in designing practical software solutions that both function user-friendly.
That's all from us. Thank you.